For today's last breakout session in this track, we have Ishan Khurana and Tom Woods from Ford Motor Company, and Kyle Hinton and Seth Jones from Slalom. They'll be talking about how Ford's platform enablement teams engage the Ford Tanzu Application Service application developer community via dashboards and reports to communicate recommended fitness applications and monitor results. I'll let you guys have it now.
Hello, my name is Tom Woods, and the group of us are going to talk about driving TAS fitness through Ford Motor Company.
I am Seth. I'll be speaking second. I'm from Slalom.
And I'm Kyle. I'm also from Slalom. I'll be speaking after Seth.
Hi, I'm Ishan Khurana, and I'll be speaking last. So let me...
Again, my name is Tom Woods. I am the supervisor of platform services, analytics, billing, and automation. My team, we measure and drive benchmarks to analyze value of Ford strategic cloud platform investments. Next slide. So among my responsibilities, I'm responsible to forecast platform usage and drive fitness. This is a high stakes thing we do. It's high stakes things I do. We need to understand true costs of proposed programs to support business cases. If I don't understand the tipping point of particular application instances, my forecast could be off by a factor of 50 or more. If you have 4 instances because of redundancy, how many more, load will you require new instances to handle new loads? So high stakes. If I forecast too low, maybe Ford shouldn't have gone that direction. If I forecast too high, maybe we might have missed an opportunity. If you look at the cartoon above, you see Pete in the guy on the left. I was a lot like Pete until Seth and Kyle and Ishan came to my rescue. Pete has to do his forecasting by a tool called PCF Metrics. It's a built-in tool to the TAS application services. PCF Metrics, you have to through a GUI, not a CLI, through a GUI, you look at your CPU utilization over time, your memory utilization over time, your transactions over time. Again, you're viewing this, a number of AI instances over time, over a short period of time. Poor Mitch has to then manually load these spreadsheets and do the best job that he can do to create forecasts or to drive fitness. So Mitch in the past would take probably 40 or 80 hours to analyze 30 application instances, and by deadline, just not wasted, but sometimes you got to do this on the weekend or late at night. And you do the best you can, and congratulations, got the job done. Now I only have 10,000 or more instances to analyze. That is not scalable. It's not tenable. We worked with our friends at VMware to get a CLI in place where we can automatically look at this metadata, this important metadata that we can gain insights. So now I'm more like Pete, the guy on the right with the Ford F-150 with the pile of money. Mitch spent all that hours to save a few pennies. Now with the tools that Seth, Kyle, and Ishan gave me, I can click a button and get a pile of money in the bed of my pickup truck. What used to be very manual, now it's very automatic, and then we can give this information to our hundreds of application teams, and Ishan's going to talk about the results of what we did. Next slide, please. This is not rocket science here. Anytime you're in an IT organization, there's always the money person. Even if you're an organization of ones, your hat one day you'd be the app developer, and the next day you'd be the money person. What Ford does for our flagship technologies is we take key performance indicators. And for TAS, it's gigabyte hours, and then we measure and analyze that. So this is not rocket science. You have your base fixed costs, people, licensing, foundation infrastructure that doesn't vary depending on load, and then your variable costs like Diego sells VMs, logging infrastructures, things that do increase overload, and divide that by your number of predicted gigabyte hours, and that is your actual gigabyte hours, and that's your rate per gigabyte hour. Just a real quick shout out to the TAS foundation engineers. Their foundation footprint has reduced vastly over the last year, which has very positive impacts on our gigabyte hour rate. Next slide. So as I said, our job is to drive fitness at Ford. One of the ways we drive fitness is by giving reports to application teams, see how they can be more, more efficient with their application instances or their service instances. Another way we do it is economies of scale. And when I talked about there are too many people, the application teams, we give them detailed reports of their application instance usage so they can make the right decisions. And then the Ford ITO teams can also track the costs and the benefits of the TAS implementation. And this is the financial part of it. There's all sorts of great benefit, 12-factor agility by going to this platform that we didn't have. I mean, the teams that used to do 2 releases a year, now we're doing 300 releases a year, and we're much more agile. But at the same time, it's also been good for the bottom line. And then the next slide. And then quickly, what do our fitness reports identify? Well, we identify lazy AIs, application instances that aren't working very hard, bloated AIs, application instances that are way too big. There could be a 3 gig application instances, and the memory max is 500 megabytes. Overstaffed AIs, some application teams have 20 AIs or application instances where 1 would do. Misplaced, unorphaned, or unhealthy AIs with a large environment at Ford Motor Company with hundreds and hundreds of application teams. Some application teams did a proof of concept and walked away from it. We can identify it, save Ford some money. Forecasting, we also said, AI applications is tipping point analysis and all sorts of other, now that we have this metadata, there's all sorts of other cool things that we can do now that we couldn't dream about with the old PCF metrics tool. And the other thing I should note is we worked with our friends at VMware on Kit tagging in place. Now we can tag the orgs, tag the AIs, tag the spaces with the application names and other important metadata that drives automation, that lets us get reports out to the people who need them. So a lot more granularity, a lot more automation. So with that, let Kyle and Seth take over. Next slide.
All right. Thanks, Tom. So my name is Seth Jones, and I'm a solution owner at Slalom, based out of Detroit. With me today, I have my solution architect, Kyle Hinton. We are primarily SRE engineers, and our goal is to work with Ford Motor Company to bring in SRE practices, specifically around observability, to really enable their product teams to make sure that their platforms are cloud ready and make sure that they're meeting all of their goals and really doing the best industry practices that they possibly can be doing today. So if you could move us on, Ishan. How did we get involved in this? Slalom is a consultancy across the United States, and we primarily focus on tech delivery. And our focus with Ford has been the latest evolution of many Ford evolutions. As you see here, in 1903, Ford was a very different company than it is today. At the launch of the Mach-E this year, they're going to bring their first 100% battery EV to the market. And in doing that, they are going to have to change a lot of their practices that they've done in the past. And over the last, decade or so, they've went from a traditional IT ops organization to kind of a cloud-first ops organization. And with that comes a lot of change, whether that's cultural change, platform change, technology change. It's gonna require a lot of work. And Kyle and I were brought in to kind of assist with that. And SRE, or site reliability engineering as a practice, is geared towards that specific task. You can move on, Ishan. So in 2017, Ford launched the plan to become the most trusted mobility company. And they made a big press release about this, and it's a great read if you have a minute. But one of the key things when it comes to trusted, in my opinion, is reliability. And in site reliability engineering, it's in the name. So bringing along that kind of mentality, Ford is pushing in a great direction to bring in these industry best practices to really take the cloud native approach to the nth possible degree, do it as best as possible. And with ourselves, Kyle and I, and the Ford team and platform enablement have been given the direction to really do what we can to make this as great of an effort as possible. So I think in becoming, kind of that reliable organization and that trusted organization, we are going to use every tool in our tool belt to do that. And using the TAS framework, we were able to kind of improve the observability of the teams, that they no longer need to have someone like Tom doing manual effort, and really give them as much insight as possible. Next slide, please. So to put a little bit of scale to this, Tom mentioned some light numbers, but here's some more specifics. We're looking at 20,000 plus application instances. It's a very, very large environment. And observability on that scale takes quite a bit of engineering work, as well as some kind of thought leadership. And how do we boil this down into something that everyone can use? We're working with 500 plus product teams. These product teams are all over the globe, various time zones, languages, and we're also looking at various PCF foundries or TAS foundries in different locations. We have TAS foundries in AWS, Azure. Ford recently moved to a lot of on-prem TAS foundries that are the teams are using for a lot of the pre-prod environments, as well as we have global data centers. There's data centers all over the world, and we needed a solution that really could monitor all of these things without hiccups, without technical problems, and without causing too much toil for the teams. So one of the things in SRE that we're really trying to push is an ease of adoption. Observability is a great tool, but only if people use it. So I have a quote here from a former Pivotal engineer, Jonathan Schneider, that said, every team should be able to develop in whatever method they want. And one of the things at Ford that I've been really happy with is that they've given the product teams the freedom to do what they want, but they're also giving them great tools to do that, like TAS. And in our tooling, we wanted to be able to kind of provide that same ease of entry. So how do we easily monitor 20,000 plus TAS applications? So the two main goals for us in this activity was, how do we provide teams with the insight to troubleshoot their apps, optimize their apps, and improve their apps, as well as roll up metrics to management and people that are interested in other pieces of information. Also, how do we do this without taking up too much of the team's time? When you have 500 plus teams, you can't spend a week with each one, onboarding them to a platform and gathering metrics and logs, things from them. So that was our second key goal, was we had to make this as streamlined as possible, make it easy to use, and being able to provide that value without sucking up too much product team time. So our solution, we came up with the idea of lenses. We were going to provide the teams with currently 3 separate lenses that give us insights into different layers of their application or delivery of information to their application. So we've got gateway metrics, which are just giving them basic insights to traffic passing through our gateways, from the internet or mobile devices to their applications hosted in TAS. infrastructure metrics, which are going to be metrics specifically coming out of the Foundries, and that's mainly what Kyle's going to be talking about today. And then application level metrics, where we're digging down into the nitty gritty of what each specific application is doing. And at Ford, most of our applications are Spring-based Java or Kotlin applications, and we've been able to leverage some of the Spring pivotal technology to really drive application metrics without too much of a hassle. So that's where it comes down to the topic of right sizing. So to Tom, he's thinking fitness of an application. He's thinking utilization. As an SRE organization or an SRE engineers, we're thinking we want to give our teams the information that they need to make sure that they're scaled up or down appropriately. We don't want them wasting resources. We also don't want them starving their applications and hindering the performance of their application. So for our task, right sizing is going to be scaling to achieve intended capacity. And that intended capacity is an important point because Ford has moved to an always connected vehicle where every car that comes off the line has a modem, and we want to be able to provide those customers with the best performance and the best service that we possibly can, and that's our intended capacity. So we had a couple of assumptions and considerations that we wanted to make sure were accounted for in this activity. One, we've already covered. We want insights without product team effort or much product team effort. Most of the product teams are software engineer centric, so they may or may not have experience when it comes to capacity planning. So we want to try and automate or simplify that process if possible. Product teams are also in charge of their own infrastructure and resources. So as our quote mentioned, we want teams to own their product. We want teams to own their infrastructure. We're just giving them the tools to do that better. We want to nudge teams towards change. And what that, Ishan will go over what that means specifically, but our goal is not to dictate change. Our goal is not to be a command and control organization. We want to give teams the information that they need to make the decision that's right for their product. We also want to leverage open source technology that allows us to limit third-party dependencies as well as maximize customization. So, within an SRE organization, we want teams to be able to adopt, manipulate, tweak, whatever they need to do or we need to do for them to best suit their needs. And then we need the ability to measure the impact of our right sizing efforts. What that means is, as we're going through this activity that we are with this fitness applications, we want to be able to show management, to show Tom, to show whoever else before our actions we were here, after our actions we are here, and we need to be able to monitor that over time and as we continue with these operations. And with that, I'll pass off to Kyle Hinton. He can take you through the how we accomplish this.
Yeah, thanks, Seth. So now that we have a little bit of background on why we're here and what we're doing, I just want to give everybody a bit of a technical insight into how we've managed to accomplish this. So if you want to move to our first slide here, Sean. So to start off, I want to give just a bit of an overview of how the architecture looks that we're trying to monitor. So Seth alluded to this a little bit, but right now Ford is running TAS Foundries in on-premise data centers. For the purpose of what we're looking at, they're essentially egress-only environments. There are also a few Foundries running in Azure, and there are also some new Foundries that are starting to be spun up in AWS that are powering some of Ford's most innovative projects. Ourselves, what we've been working on building is this observability platform. This is hosted both on-premise to cover those things that we need to access there, as well as having a core capability center in Azure. I'll go a little bit more into what we actually have running there in our further slides. So if I go to the next one, Sean. So the first thing we kind of had to figure out when we started all of this, because Seth and I actually started on this road completely independently of where Tom and Ishan did. So at the time, we were not aware of the work they had done with PCF Metric Store. So for our standpoint, we were trying to figure out what is the fastest way that we can get all these metrics that we want out of the TAS Foundries, and to do it in a way that will integrate most natively with our platform. So we make extensive use of Prometheus, and with a bit of Googling, we found that there was a Prometheus BOSH release that could be installed on all of the Foundries. With this, it provided a number of metrics exporters that could be scraped and provide us with metrics out of the clusters. So for ourselves, we've been most interested in the CF exporter, which provides a lot of metadata around our applications. So it will tell us things like where the application is running, what its memory quotas are, if it's started or stopped, as well as the fire hose exporter, which is actually looking at the metrics for the application. So that's where we can find out on an instance level, how much memory is this application using, how much CPU is it using, how many requests does it have, the real detailed information that we want. Beyond that, the BOSH release will also install a number of other exporters. So you can get information about all of the different compute nodes in your cluster if you need to monitor that. You can get information about the BOSH system, and it installs exporters for a number of different subsystems that you may have installed as well. So once we had this in each of the Foundries, we had our source of data, but we still needed to be able to centralize it in. So if we go to the next slide, Ishan. So this is where we start to look at our observability platform. And we are focused on data aggregation at a global scale. So as I mentioned, the Foundries are running in multiple different services. They're also running in different places around the world. So there's a lot to monitor globally. So our system, we have Prometheus servers. Some of them are running on-premise in those data centers to monitor those things that we cannot reach into as they're in egress-only environments. And we also have Prometheus servers running in our Azure cluster to monitor more cloud-based services. To bring this all together, we're heavily utilizing a CNCF project called Thanos. This basically provides a top-level overlay of multiple Prometheus servers so that you can provide Thanos queries. It will go out and run that same query on all of its sub-Prometheus endpoints, aggregate that data, and bring it back to you in a single view. It's a very, very powerful tool to bring this metrics data to life. So we kind of utilize two main aspects of Thanos to cover our different environments. So where we have our Prometheus servers in the cloud that we can access directly, we utilize Thanos Sidecar. This allows us to run queries directly into those servers and get the data back immediately. For our on-premise environments, where we can only push data out, we heavily utilize Thanos Receive now, which provides a remote write endpoint for the Prometheus servers to push their data out to. So this is how we've managed to solve that problem of running in multiple different environments with different needs of how they can process data. So go to the next slide, Ishan. So I've kind of given a little bit of overview of how we're getting that data, how we aggregate it. I want to talk about how we're actually processing some of that data. So when Seth and I started this whole process, we kind of had a real goal to be able to provide these memory quota recommendations in real time to application teams. So we started out with a Python script that was able to go out and query all of our data in Thanos, pull that information down, run our analysis on it, and give us a recommendation set out in a CSV file. Very MVP product. And unfortunately, this took about 55 minutes to process all of the environments. Absolutely not real time, fell far short of our goal. And so the big problem we had here was that there was just an overabundance of raw data. So for note, we process over 4 billion points of metrics every single day. It's a lot of data there. So what we've made use of are Prometheus recording rules. What this allows us to do is to take that data as it's coming in real time and to perform some aggregation and analysis on it before we ever actually push it off to people and use it for our analysis. Now, normally you would hope that this would be as easy as writing a few queries and getting your data out. But of course, nothing's ever quite that easy. So we've had to overcome a few different issues, as you always do. We have times where our on-prem clusters, or even the cloud clusters, or the Foundries, the Prometheus service there might stop responding, whether that's due to excessive load, them being upgraded, network traffic issues. You'll have weird blank spots in your data that you have to be able to process around. We've also found very intriguing random scenarios. So the CF exporter and the Firehose exporter both like to communicate their data by application ID. When we're presenting it to customers, we want to be able to let them search by application name. Well, if they change the application name in their TAS Foundry, the ID doesn't change. So now we end up with a weird one-to-many data relation that's very interesting to work around. So we've had to come up with a few different clever points, but eventually we did manage to get that all functioning and working as expected. So now with that ability, instead of us taking 55 minutes to process all of those applications, we're now able to provide recommendations for thousands of applications across an entire cluster in under 10 seconds. So this gives us that truly real-time ability to present this to teams. Shall I move to the next slide? So we have all this data now. We've got our ability to process it. We can generate it really fast. I want to give it information on how we're actually using it. So as Seth kind of talked about, a lot of the teams at Ford, they're very new to a lot of these concepts of capacity planning and these metrics-driven decisions. So we wanted to come up with a capacity model that was very simple at first, just a very first pass to get them on board and comfortable with this idea. So what we decided on is that we want to give teams a recommendation so that their application, on average, will use about 65% of their memory quota. But we also pay attention to spikes. Obviously, some applications will have spiky traffic, so they might be at 20% memory utilization at some points in time and randomly use 90%. So we also take that into account and make sure that our recommendations will never allow your application to run above 90% memory. To get this to people, we have provided two different displays using Grafana. So one of these is a high-level overview dashboard where teams or just managers even can come in and select applications from all the way at a Foundry level down to a single application level to see their average memory usage, their max memory usage, their quotas, and our recommendations. We've also integrated this with application metrics dashboard that we provide that gives much more detailed application telemetry. These are things that we expect teams to be looking at much more often. So we wanted to put these recommendations someplace that's going to be where they're looking very often. So it's very in their face. It's something that they're used to seeing, that they could understand why we're presenting it to them. It's kind of on that note that I want to talk about something else that we've kind of created as a core tenet of our system. And that's data transparency. So for us, and as part of an SRE culture, it's very important that information that's not PII can be exposed as openly as possible. So with our metrics, anybody who is a member of Ford can come in and see these dashboards. And this is really important because it allows teams to start to build off of their own successes and also learn from each other's failures. This is going to help teams continually grow faster and faster and adopt these processes faster. And as Sean will show, we've actually kind of seen some of the results of this just word of mouth spread, which has had a pretty impressive impact. So if I go to the next slide, Sean, here. So I just wanted to provide a couple of examples for our dashboards. So this is the application telemetry dashboard that I was describing here. So the two important pieces that I want to show are in the top left corner here. So you can see that we provide your current application memory quota that is coming out of the TAS Foundries from that CF exporter. And right underneath of that, we're providing our suggested memory quota. We want that to be one of the first things that you see when you turn this dashboard on. As for Ford, it's a very critical piece for cost savings. If you can go to the next slide here, Sean. And so this is the other dashboard that I was mentioning. This is a high-level table that you can go through. So we basically just provide variables at the top of the page where you can select from a single Foundry, and from that you can select all the way down to a single application. You can also see in our right-hand column here, so one of the things that we also found that's worth mentioning in working with some of the engineers for this product, that certain build packs require certain minimum values of memory for them to actually be able to start up. So this is another thing we had to take into account as we're providing these recommendations. So as Seth stated, a large majority of the applications are based on a Java build pack. And that generally requires at least 756 megabytes of memory to start. So we set that as a baseline for our applications that we won't ever recommend less than that. In the future, we hope to be able to actually tie in with that build pack information to be able to tune those suggestions exactly to which build pack you're using. So just want to move on to the next slide here, Sean. So to finish up, I just kind of want to talk about some of the future enhancements that we're hoping to bring in. So one of the big things that we're working on right now from our SRE team are to bring in more data sources. So as Seth mentioned, we have a library that we provide to teams who are using Java or Kotlin and Spring. It gives us very, very detailed application telemetry. We're also looking to bring in logs and distributed tracing into our system. And with this, we really hope to be able to provide a much better resource utilization profile for applications so that we can give them better ideas of not just, hey, put your memory at this, it'll save you some money, but that we can start to look at things like, where are your users at? Is that in line with where you're hosting your application? Are you scaled appropriately to the number of users that you have? We've seen a lot of teams where they have 7 instances of an application running because they think that's what they need. But with this data, we'll be able to actually show them, hey, maybe you only need 3. You can save a lot of money by cutting off those extra 4. And around this as well, we also hope to be able to give teams a bit of a better understanding around what their failure domains are as they're using these, how they can better design their applications for failure, and continue to making efficient products. So with that, I'll pass it off to Ishan to describe a bit of what we got out of this.
All right. Thanks, Kyle. So we sent our initial fitness reports, our communications out to the app teams for 1 out of our 4 on-prem Foundries, which we call EDC1 pre-prod. This one Foundry has 19% of all of Ford's TAS app instances. We specifically targeted 516 Ford applications, which equals out to around 485 TAS orgs that we found contained app instances that could potentially have their memory downsized. And we actually found that within this one Foundry, 31% of all the app instances were considered what we consider to be potentially over allocated. So they had more memory than allocated than what was required. Like what Kyle had mentioned earlier, we created some suggestions for app instance memory sizes based off their historical utilization. So this would result in a 65% maximum average memory usage with a 90% upper limit on memory utilization. So yeah, this would reduce the app instance memory sizes while minimizing any risks to performance. And then we aggregated some of this data additionally and some of the recommendations so that they could be searchable by Ford application. And we kept links to the Grafana dashboard for more detailed app instance level metrics. Sorry, it looks like my computer's froze up. Okay, so some of the effects of these fitness reports. The week after we first sent them out, we found the total memory allocation in EDC1 pre-prod decreased by around 1,800 gigabytes just from the app instances being downsized. And what was interesting was that we targeted in total around 3,400 application instances, and we found that actually 4,300 had been had their memory reduced. And this is likely because the teams that receive these reports, they receive these reports that were targeted towards specific app instances or specific orgs. But it looks like a lot of them reduced their app memory sizes across the board. So we found that if we saw these same reductions continue for over a year, it would yield a 16 million gigabyte hour total decrease for the whole year, which is around 15% of our scalable platform load. Then we just create a quick fitness FAQ just to help guide some of the teams on how they can adjust and monitor their app instance resource allocations, memory sizes. So this photo is kind of a quick snapshot of what we sent to some of these teams. On the left, where it's blurred out, you have the Ford application details. And on the right, you have some of the aggregated metrics like historical utilization and the number of app instances. And what's missing is where you could click the dashboard link and see all of the app instances that fall under your Ford application, all the detailed metrics for those instances. So some next steps for these reports. We would first just like to create some additional memory kind of size guidelines to developers when they spin up a new org or app instance. Then we would want to continue sending out these fitness reports to the rest of the total 11 boundaries. So we started with 1, we have 10 more to go. And we'd want this to be a recurrent communication with the app teams to kind of keep this TAS fitness initiative going. We would also maybe like to include some additional resource utilization metrics, as well as identify orgs and spaces that can just reduce the number of active app instances rather than just reducing the memory sizes of the app instances that are already running. Then using all this data that we've collected and we have access to now, we could potentially train supervised models to forecast the future resource utilization. And using that, we can identify app instances or orgs or even Ford applications that are trending towards becoming over or under allocated for memory. And I believe that ends our presentation. So thanks everyone for tuning in.
If you have any specific questions, please join us in the Q&A session after this, and we would love to dig into the details with you, answer your questions, or go over any other things you have you'd like to ask. So thanks for joining us.
Thanks, all of you. That was really cool. Yeah, as I said, you can head over to the Q&A session, and also this ends the last breakout session for this track for today. And the next thing is if people want to go over to the main stage. So thanks for coming, everyone.